Okay, good morning, dear participants. So today I will be discussing with you an important spectroscopic method as far as research is concerned, and that is IR spectroscopy. So today's session is basically divided into two parts. One, I will be discussing with you theoretical part of IR spectroscopy, and second one, I will discuss with you how to plot IR spectrum using Origin software. So one hands-on that is demonstration type of part, and another is simple theoretical background, which is quite essential for research purpose. So topic of my today's talk is IR spectroscopy applications in research, a comprehensive overview from fundamentals to masterpieces of art. So dear scholars, we know that the IR spectroscopy deals with interaction of infrared radiations with the matter. And it tells us the information about molecular vibrations, and it is quite useful for the determination of functional groups present in the sample. An important aspect of IR spectroscopy is it is a non-destructive technique, and we can recover the sample which is analyzed using IR spectroscopy. If we compare IR spectroscopy with mass spectrometry is a destructive technique, and when we analyze the sample using mass spectrometry, we cannot recover the sample as sample undergo decomposition. This is not the case as far as IR spectroscopy is concerned, as it is non-destructive, we can recover the sample. So basic principle of IR spectroscopy is that there is interaction of infrared radiation with the matter. Now, as I told you that there is an interaction of infrared radiation with the matter, what these interactions gives. So whenever infrared radiations interact with the matter, interact with the sample, there is an vibrational transition from lower energy level to higher energy level. All these transitions are governed by Hooke's law, which is nu is equal to 1 upon 2 pi c multiplied by under root k upon mu. So I would like to ask the research scholars about the various terms involved in the Hooke's law so that we can proceed further. Can you tell me what is k and mu in the Hooke's law? Dear scholars, yes, absolutely. That k is the force constant and mu is what? Mu is reduced mass. So both these terminologies, both these concepts are very important as far as our spectroscopy is concerned. That is force constant and Hooke's law. So as I told you, whenever molecules absorb the energy, infrared energy, and undergo vibrational transition, this vibrational transition or absorption of higher radiations causes the molecular vibrations. These molecular vibrations are basically divided into two parts. That is stretching and bending. As you can see in this figure, there are two types of stretching, asymmetric stretching and symmetric stretching. And there are four types of wagging modes of vibrations. These four wagging modes of vibrations are, extremely sorry, there are four types of bending vibrations. These bending vibrations are wagging, rocking, twisting, and scissoring. You might be knowing that stretching vibrations require more energy than bending vibrations. And out of the two stretching vibrations, symmetric stretching and asymmetric stretching, asymmetric stretch requires more energy. Therefore, it requires higher frequency. As we know that energy and frequency are directly related to each other. They are directly proportional to each other. Symmetric stretching vibrations require more energy than symmetric stretching vibrations. And when we compare stretching and bending, obviously stretching requires more energy than bending. Therefore, stretching vibrations are at higher frequency value than bending vibrations. This is already covered in earlier classes, that is at undergraduate and postgraduate levels. So I will not spend more time on this. So as I discussed with you, two important parameters are there, force constant and reduced mass. So it is very important to understand the basics about effect of bond strength, that is force constant on IR stretching frequencies. So if we compare, I have taken a very simple example over here. So there is carbon-carbon single bond, carbon double bond carbon, and C triple bond C. So if we compare the bond strength, that is nothing but force constant. So triple bond will have higher force constant than double bond, which is in turn having greater force constant than carbon single bond carbon. And I told you that frequency is directly proportional to energy. That is nothing but frequency directly proportional to force constant. So as force constant increases, the stretching frequency in IR spectroscopy also increases. So C bond, that is carbon single bond, vibrates at 1000 to 1200 reciprocal centimeter. Carbon double bond carbon in between 1600 to 1680 reciprocal centimeter, and carbon triple bond carbon are in between 2100 to 2260 reciprocal centimeter. So this is governed by strength of the bond. And if you go to the reduced mass, so the basic theory is that frequency is inversely proportional to square root of reduced mass. Here, the lighter atoms vibrate faster, heavier atoms vibrate slower. So higher mass means there will be lower frequency. I have taken a very simple example in which the hydrogen atom is replaced by deuterium. And when we replace hydrogen atom by deuterium, we know that deuterium is having heavier mass as compared to hydrogen, that is proton. So as mass increases, frequency decreases. So you can see that carbon deuterium vibrations are located nearly 2100 to 2200 reciprocal centimeter, whereas CH stretching vibrations are in between 2850 to 3000 reciprocal centimeter. So these two basic theories already we are knowing. So I will go further. So dear scholars, we must know what are the regions of IR spectroscopy. So there are basically three regions: near IR, mid IR, and far IR. Near IR includes the region from 14,000 to 4,000 reciprocal centimeter. Mid IR includes 4,000 to 400 reciprocal centimeter. And far IR is in between 400 to 10 reciprocal centimeter. As far as applications are concerned, near IR is used for food analysis, pharmaceutical quality control, moisture analysis, etc. Far IR is used for studying inorganic complexes, polymers, solid state materials, and the very important region as far as research is concerned is mid IR, which falls between 4,000 to 400 reciprocal centimeter. And this region is very, very important for the identification of functional groups, structural analysis, and this gives us FTIR spectroscopy. Now, importantly, as far as mid IR is concerned, the functional group region is very important. And here in this, I have taken a very simple image which will give us idea about the various types of functional groups which are present in the molecules. So in this diagram, you can clearly see the carbon single bond vibrations are at lower frequency values than carbon double bond vibrations, and carbon triple bond vibrations are at higher frequencies. So they are directly related with the bond strength. And we know that bond strength increases as number of bonds increases. Whenever instrumentation part is concerned, we must know what kind of instruments are good, what kind of instruments are better for giving you perfect IR spectrum. So while choosing the instrument for characterization purpose, we must focus on IR sources, what kind of wavelength selection is needed, what kind of detectors are important, and sample handling phenomena. So whenever we are choosing particular IR instrument, so in the IR instrument, the radiation source may be Glober, silicon carbide rod, or it may be Nernst Glover. How it is constructed, you can see, as I told you, Glober IR source is an electrically heated silicon carbide, whereas Nernst Glover is rare earth oxide ceramic, and it can withstand a temperature close to 1900 degrees Celsius. So by comparing these two IR sources, you can easily make a conclusion for effective IR source. So you can see various advantages are there. As far as Nernst Glover IR source is concerned, it is having high intensity and it is good for mid and far IR analysis. And the limitations of this Nernst Glover, it requires preheating and it is less stable. But we can employ it for high intensity air applications as it can withstand high temperature. Now, wavelength selection is also an important parameter in the air instrumentation. So, monochromators are used for providing wavelengths or interferometer, that is FTIR. So how that monochromators are constructed? They are of made up of prisms or gratings of separate wavelengths. And interferometer is nothing but Michelson interferometer that provides the interferogram. And we know the principle of any Fourier transform. That Fourier transform is a mathematical terminology, and that Fourier transfer converts signals to spectrum. That is very important concern. When we talk about FT-NMR, in FT-NMR also, that Fourier transform plays an important role to convert the analysis into the spectrum. It is a mathematical model, Fourier transform. And what is important thing about the FTIR? It gives us very high signal to noise ratio. And this is very, very important aspect. Whenever we have to analyze the samples containing trace amount of impurities, that analysis of trace samples, analysis of impurities, as far as purity is concerned, that signal to noise ratio is considered as important parameter. For an good IR instrument, this signal to noise ratio should be very high. So this is the advantage of interferometer. And it is a modern research grade IR instrument whenever there is presence of this type of instrumentation. There are two basic types of detectors, DT, GS, and MCT. That DTGS is pyroelectric detector and MCT is photoconductive detector made up of HGCD, T is semiconductor. And this is very important, MCT, for trace analysis. And as far as DTGS is concerned, that is general and routine for laboratory purpose. When we talk about the sample handling, so there are basic three types. The KBR pellet method, which is an outdated method. The advanced and modern sample handling method is ATR. So the modern IR instrumentation contains ATR technique for sample handling. What is KBR pellet method? Whenever sample analysis is concerned, the solid samples are mixed with dry KBR to form an pellet, which is analyzed by the instrument. So, as I said to you that there is mixing of solid samples with the dry KBR. So this statement itself indicate there is a limitation of this technique. So can you tell me what will be the limitation of this KBR pellet method? If you know the IR spectroscopy and if you know what to be analyzed, you can easily tell me the limitations of KBR pellet method and why it should be avoided. Dear research scholars, can you point out the limitation? Okay, I will tell you. So, as we are mixing solid sample with the KBR, so we can analyze only solid samples. Another important thing, the KBR should be dry. So whenever we are analyzing the sample and this KBR is not dry, it is having moisture, then that will interfere in the analysis. I will show you this in the spectrum. And as far as ATR technique is concerned, we can analyze any type of the samples. So this is very, very important thing. And there is no need to prepare the sample. Keep the sample in the IR instrument and you can record the IR spectrum within an minute, less than minute. So which technique is preferred in the modern days? It is the ATR technique. So while purchasing the IR instrument, these things are very important, and every researcher, every research scholar, every faculty member must know what type of instrumentations are there in the IR instrument. So while selecting the a better IR instrument, we must know what are the best options in each category. So best IR source, as I discussed with you, is a Glober. Then wavelength selector is interferometer, that is FTR interferometer. Detector is MCT. Advantages are shown here. And ATR method is the best method for sample handling. So whenever you will perform the analysis of your samples, you must ask the analyzer that what kind of specifications are there in the IR instrument, because correct specification will give you a good IR spectrum. So whenever performing the IR analysis, the signal to noise ratio is very important, and this can be achieved by presence of these types of instrumentations. So as I discussed with you, a very, very important aspect in IR spectroscopy is signal to noise ratio. So signal to noise ratio depends upon scan time, resolution, detector type, ATR technique or transmission technique, source stability. These are very important things. We must check before purchasing the IR spectrophotometer. And second point is detector. And this is very important for the sensitivity. So different types of detectors are there. We must go for good detector. Third important aspect is vacuum versus purge versus ambient optics. So there are some important things we must go for. That vacuum, as it is having high stability, it removes the background interference of water and CO2. And as far as resolution is concerned, the resolution should be very high, and it is directly related to signal to noise ratio. The high resolution in between 0.07 to 0.09 reciprocal centimeter is important. Now, As far as applications of higher spectroscopy is concerned, in organic chemistry for the structural analysis, it gives us idea about identification of various types of functional group, various types of carbonyl compounds, hydroxy compounds, compounds having NH, nitrile, aromatic, olefins, carbon heterobonds, all can be identified. And a very important thing, IR spectroscopy, as it gives you the results within a minute, we can monitor the reactions. So whenever you are performing any kind of reactions, then that immediate analysis of the product is very important. When you analyze the organic product within a minute, you can make a conclusion whether your product is pure or it is having some impurity of starting material or any other impurity. So as it requires very short period of analysis, this IR spectroscopy, we can monitor the reactions like TLC. So we usually monitor the reaction by using thin layer chromatography. But when we have this instrument in our laboratory, we can monitor the reactions and we can see what kind of functional group change has occurred during the reaction. Whether desired functional group change has taken place or not, we can confirm. A very important application of our spectroscopy as far as organic chemistry is concerned, we can study different types of hydrogen bondings and also various kinds of interactions. We know there are two types of hydrogen bonding. One is intermolecular, another is intramolecular, and we can easily distinguish between these two types of hydrogen bondings, and we can also make a conclusion whether a given sample is having hydrogen bonding or not. As we know that presence of hydrogen bonding lowers the frequency. So this is very important thing. We can find out the stereochemistry, we can find out the conformational changes. As I told you, we can find out the functional group. So we can, whenever your reaction is having a protecting group, insertion and removal of protecting group, whether a particular group is protected or deprotected can be determined. Charge transfer complexes can be studied, and as I discussed with you, we can determine the purity of the samples. Now, a very important thing about the IR spectroscopy is it is very, very sensitive technique. A very small amount of any compound can be detected. It is very, very sensitive technique. So one of my student was synthesizing this compound, and we were getting two spots in the TLC. As we were observing what might have happened during the reaction, we were quite confused. But we took an IR spectrum and observed the IR spectrum, and we made the conclusion that this compound, which is having an ketone group, it may undergo an tautomerism. You might be knowing what is tautomerism. So that is shift of proton from one position to another position, also called as prototopy. So this compound is having an carbonyl group. So it can go and tautomerism from an carbonyl group to hydroxy group. And here you can see the right side is favoring the reaction in acidic medium as it is having an aromatic nature. And aromatic compounds are quite stable. So this conversion we determine by using the IR spectroscopy. So monitoring reaction becomes easy when you have this instrumentation. So we can employ the IR spectroscopy in pharmaceutical chemistry for the identification of drug, polymorph analysis, moisture detection, degradation and stability. We can also employ the IR spectroscopy in biochemistry, proteins and biomolecules for the determination of protein structure, type of amide linkage present in the protein, protein aggregation study, the peptide bond formation study, enzyme substrate interaction is also important aspect which can be studied by the IR spectroscopy, and all other applications you can see over which are given here. And very importantly, we can use this technique for the analysis of polymers, analysis of materials, various types of parameters can be studied by using IR spectroscopy. And we can go for analysis of nanomaterials. Various types of nanomaterials can be studied. Various types of doping concepts can be studied by using IR spectroscopy. Whether you are using inorganic dopant, organic dopant, concentration of dopant, from the height of the peaks, from the peak intensity, we can compare various types of dopant concentration, type of dopant used. Everything can be studied by using IR spectroscopy. The surface phenomena can be studied by using the IR spectroscopy. These are various applications of IR spectroscopy such as environmental and atmospheric research, food science, forensic science, geology, mineralogy, earth sciences, biomedical and clinical applications, catalysis and surface chemistry, industrial processes, gas phase and physical chemistry, crystallography, solid state chemistry, surface and coatings. And this another important thing, that is spectroscopic imaging and mapping. So you can see in each and every field, there are applications of IR spectroscopy. But whenever we analyze the sample by using IR spectroscopy, we must know what kind of interferences, background noises create problems in IR spectra. So the first and most important problem, which is very, very common that occur in the analysis of sample by IR spectroscopy, is water vapor and carbon dioxide. So we know that the atmosphere contains moisture, nothing but water vapors, and there is ample amount of carbon dioxide. So whenever water vapors are there, it gives broad signal and that appear in between 3700 to 3100 reciprocal centimeter. And that is due to OH stretching in water molecules. Another signal that may occur due to water vapor is due to bending vibrations that occurs close to 1630. And this carbon dioxide gives a signal at close to 2300 reciprocal centimeter. That is to the presence of CO2. There may be presence of solvent and contaminant signals. So whenever you are analyzing, as I told you, the moisture can interfere. And whenever you are cleaning the position where you kept the previous sample, the solvent used for cleaning purpose, such as acetone ethanol, may also interfere if it remains on that surface. Their signals may appear in your IR spectrum. So solvents, contaminants can give you interference while analyzing the IR spectrum. Instrument related problems are baseline drift. You will not get a good spectrum. The spectrum will look very sloppy. Wavy patterns you may get, random peaks may occur. So you must identify which type of problem is there in the analysis. So how you will avoid all these things? You have to run a fresh background scan before analyzing the sample. It is very important to purge the instrument with dry nitrogen to remove the moisture and carbon dioxide. And we have to keep the ATR crystal very clean, air plates very clean, and we'll make sure the samples are dry samples. If you are using the KBR method, which is very old method, the KBR should be kept in desiccator to avoid the contamination by the moisture. And we have to make sure the solvents are evaporated after cleaning the plates. And we have to make sure the compartment, chamber where IR instrument is kept should be closed so that there will be no interference due to moisture and carbon dioxide. Okay. Now, if you have any kind of query related to the things which I have discussed, you can ask. If you don't have any query, then I will go for the characterization part. And after that, plotting the IR spectrum using origin software. Is there any concern regarding the theoretical part which I have discussed with you? Any concern? If you don't have any concern, I will go further. As you are an research scholar, I have not taken any kind of thing which have already studied in your earlier classes. I have tried to give you idea about the research related things. Okay. So those who are listening the lecture are replying, okay. If you have no query, I will go in the analysis part.
Sir, please see the chat section. There is one question.
Okay, okay. Let me see. Sir, can you please tell us one more time the difference? Okay, IR, difference between IR and FTR. No issue. So, as we have discussed in the instrumentation, that we uses two different types of wavelength selectors. Either we can use monochromator or we can use interferometer. that is Michelson interferometer. So what is the basic difference between these two? Whenever we are using monochromator scans the wavelength one by one. But when we are using the FTIR analyze the sample by collecting all the wavelengths. So there is simultaneous analysis of all wavelengths in FTIR, and whenever there is a simple IR, conventional IR, it is having monochromator, and the monochromator, as it is scanning, analyzing, collecting one wavelength at a time, it will require greater time as compared to FTIR. FTIR technique not only sensitive, but also it requires less time as compared to conventional IR. So FTIR is very fast, high sensitivity, and it is also having good resolution. So these are the very important advantages of FTIR. Whenever you will talk about FTNMR and conventional NMR, there are very good advantages of FTNMR over conventional NMR. As FTNMR is very rapid, all signals are recorded simultaneously as compared to conventional NMR, that is continuous wave NMR. Similar thing is there. When we are using monochromator, that is traditional IR instrument, and when we are using interferometer, that is FTIR. Is this clear to everyone? I think this is clear, quite clear. Okay. Now, I will take one example from my research study. Okay. One more question. For solid compound having range of 4000 to 400, but liquid having which range? What is the important thing? This is the mid IR region, which I discussed with you, 4000 to 400. This sample, whatever may be the nature of the sample, whether it is solid or liquid, the analysis depends upon the force constant and the reduced mass. And the functional groups which are present, that gives us idea about the region where signals will occur. Suppose liquid sample is having, let me take one example. Hexane is the sample. Okay, hexane is a liquid which is having 6 carbon, hydrocarbon. So it is having CH group, and CH groups will show signal close to 2800 to 2900 reciprocal centimeter. Similarly, if we take example of acetophenone, which is also liquid, it is having carbonyl group. So it will say, show signal in between 1700, be close to 1700 for carbonyl. Aromatic carbon double bond carbon will be close to 1600 to 1500, and other signals as expected. So say, whatever may be the sample nature, liquid or solid, the signals, the frequencies depends upon the composition, structural arrangement, what kind of functional groups are there. I think this is quite clear. Any more question from your side? I think there are no more questions. Okay. I think I have tried to answer the questions. Is everything clear?
Yes,
Okay.
sir.
Okay. Now this is the compound. So I would like to ask all the students here, as all belong to science. So chemistry was the subject at 12th standard, 11th standard, 12th standard, 10th standard, FY, SY, maybe for the chemistry student at higher level also. If electronic science students are there, they might be having only up to SY or FY level. Okay. Can you tell me what kind of functional groups are there in this compound? Can you guess? Okay. It is having an ester group, amide group, and in amide we have carbonyl and NH. Correct? Now we must know in NMR session also, I told you that for the interpretation of any data by spectroscopic method, the theoretical background is very important. So we must know the regions where signals will appear. So let me tell you that an carbonyl group of ester is having an frequency close to 1740 reciprocal centimeter. Correct? And the amide is having an frequency close to 1680 reciprocal centimeter. And depending upon type of structural arrangement present in the compound, these frequency vary. Whenever conjugation is there, frequency decreases. And wherever heteroatom is adjacent, then heteroatom is adjacent to carbonyl, that frequency increases. Ester is having greater frequency than ketone. The reason is quite simple. Carbonyl is next to oxygen. Everyone is knowing here. So here we have an ester group, an amide group, aromatic ring. So there will be carbon double bond carbon frequency. We must know this thing first of all. There will be carbonyl frequency. There will be NH frequency. There will be carbon double bond carbon frequency, an additional carbonyl frequency. And it is also having and sp3ch. You can see here. This isopropyl group, ethyl group, CH3, all are sp3. And sp3 stretching frequency are close to 2800. sp2ch frequency are close to 3000. NH stretching frequencies are at 31002 to 3300 reciprocal centimeter. So CH-sp3 lower frequency, CH-sp2 frequency higher frequency, and NH and OH are at higher value than sp2ch. So we have an order: sp3ch, sp2ch, NH and OH frequency. Okay, let me show you this IR spectrum of this compound. Okay. So dear research scholars, we have different sets of frequency. First of all, let me tell you that the IR spectrum is a plot of percent transmittance versus wave number. So on this axis, here you can see percent transmittance is given. So it is a plot of percent transmittance versus the frequencies. Frequencies, wave number, that is wave number in reciprocal centimeter. So the range is 400 to 4000, you can see here. So we have different types of frequencies in this IR spectrum. Okay. So let me tell you, as I discussed with you, NH are having frequencies at higher values, NH and OH. Okay. So here we have two NH group. So two NH frequencies are expected. Can you see here at this position? So two NH bands are observed. One is close to 3100 and another is close to 3224. So this belongs to NH. Is this clear to everyone? Is this clear to everyone? So that we have assigned the NH frequency. Okay. Now you can see two signals here at 2839 and 2939. All these signals are due to sp3 stretching. Which stretching? sp3ch stretching, when we are having sp3ch. And we have an carbonyl frequency, you can see here. At what position it is located? 1712. That is for ester group. But you just told me that an ester group is having frequency close to 1740. The carbonyl stretching frequency of an ester group is 1740. But we have obtained an peak at 1712. So it is at lesser value as we are we have expected. So yes, absolutely, it is due to conjugation. Conjugation decreases the frequency, not shielding. Shielding takes place in NMR. So here you can see this carbonyl group is next to double bond. You can see, and this double bond undergo resonance, and resonance increases the bond length, and bond length increases, force constant decreases, frequency decreases. So carbonyl. So you must conclude, you must explain the IR spectrum to your research guide, or whenever you are explaining your research to the audience in the conferences, in your presentations. So here frequency is at lower value. You must identify, you must find out what are the reasons of for frequency change. Always remember. Now we have another frequency at 1651. Can you see here? That belongs to which group? Can you tell me that belongs to which group? That belongs to which group? That belongs to second carbonyl ring. So second carbonyl group. This one, this carbonyl group, this carbonyl group. And as we discussed, carbonyls are having frequency close to 1680. But here you can see carbonyl amide having frequency close to 1680. But here you can see the carbonyl group is next to and nitrogen to its both sides. So there is nitrogen adjacent to carbonyl decreases the frequency. Exactly opposite to oxygen. Oxygen next to carbonyl increases frequency. However, nitrogen decreases the frequency. So that carbonyl group, which is flanked between two NH group, will result in lowering the frequency. So it is at lower value. Another thing which I would like to ask, as you are observing the IR spectrum, here the peak intensity of this carbonyl group, this signal, you can see it is having more height than this one. Can you tell me on which concept the intensity in IR is determined? Can you tell me which factor determines the intensity of a signal? You might be knowing that The change in dipole moment is the basic thing, required thing for and compound to show the IR spectrum. For a molecule to show the IR spectrum, the basic thing is that it must undergo change in dipole moment whenever we provide the IR energy to the sample. Polarity is very important aspect. And this polarity governs the intensity. Always remember this thing. And remaining things we can easily analyze. So we have and signals close to 1500, 1600, 1500. All these goes to carbon double bond carbon. So these are the basic about various types of functional groups present in this compound. Okay. Other signals I will not discuss. There is presence of carbon single bond oxygen, then carbon single bond nitrogen, all other signals you can observe. But this part, which I have discussed with you, is the most important as far as this structure is concerned. Let me take another example, this one. Okay. So my question to all the research scholar is that what is the basic difference between these two structures? Important basic difference. What is the basic difference between these two structures? Can you tell me? Can you tell me the basic difference between these two structures? Is there any student who can tell me? Okay, what is the answer from your side? Yes, it is having ketone. So an ester group is changed to ketone. Okay. And we have also Cl. So if we observe the IR spectrum of the second compound, let me show you. You can see the first spectrum clearly so that we can compare. So this is the spectrum. So again, I am showing you. This is the first spectrum and this one is the second spectrum. Okay. So can you locate the frequency? Can you locate the ketone frequency in this compound? Can you locate the frequency of ketone? Yes, you can easily. You can see here the frequency. As I told you, for a ketone and frequency is close to 1700. So here you can see the frequency which is lowered now. So initially you can see in the first spectrum the frequency was 1712. But that carbonyl frequency is now 1674. Ketones are having frequency at lower value than esters. And ketones are having close to 1700, but it is quite lower again due to conjugation. And the amide frequency is not observed. Why not observed? As I told you, the instrument plays an important role for analyzing each type of signal. If there is any kind of problem in the instrumentation, some signals may overlap, merge, and that will not give you fine IR spectrum. And this IR spectrum is not fine. You can see it is not a very good IR spectrum. So is there any problem with the compound which is analyzed? No. Compound was absolutely pure, but there might be problem in some instrumentation part. Okay. Now, if we compare both the spectrum, again, I would like to tell you, can you see these two small peaks which are close to 13, 3700? Can you see these two signals which are not labeled by the analyzer? Can you see these two signals? Can you tell me to what groups these signals which are close to 3500 belongs? Can you tell me? Is there any group in this compound? So this is spectrum of first compound. Let me tell you. The spectrum of second compound is this one. Now here these two peaks are labeled. You can see one signal is at 3626 reciprocal centimeter and second signal at 3711 reciprocal centimeter. So same signals are there in the first compound also. So here you can see. And say here you can see. This signal belongs to which groups? What are the reasons these two signals have appeared in the higher spectrum? Can you tell me? If you, you have listened the lecture carefully, I have already told you while discussing the interferences in the IR spectrum, why there are interferences, what kind of interferences are there, how to avoid these interferences, already discussed by me. No student is telling why. Uh, why these two signals have appeared? Is there any problem with the compound? Or the problem in instrument or the problem while analyzing the air spectrum? No one? Are you listening the lecture? Or you have kept your phone or PC on silent mode? I don't know what are you are doing. This is the advantage of listening the lecture through online mode. Okay, I will tell you. If you have seen all slides clearly, I told you here the common interferences and background signals in the air spectrum due to water vapors, where the signals appear close to 3700. And there is another interference in the air spectrum due to presence of atmospheric carbon dioxide. So atmospheric water vapors and atmospheric carbon dioxide, they interfere in the air spectrum. So you must debate that the atmospheric signals have appeared in the air spectrum. They do not belong to your sample. Remember this thing. Sample is not having water impurity. Sample is not having carbon dioxide, but they come from atmospheric contamination while doing the analysis. So the carbon dioxide signal, you can see it is close to 32350 and the water vapor signals are close to 3700. So if I show you the IR spectrum in the first compound, here two signals, they have arisen from water vapors, and you can see here one more signal here. Can you see the signal at 2337 reciprocal centimeter? Organic compounds, unless and until they are having nitrile group, they will not have signal in this region. Nitrile groups are having signal at 2250 reciprocal centimeter. Triple bonds are having signals at double two zero reciprocal centimeter, double two double zero reciprocal centimeter. So in between 2200 to 2250, we have an triple bond of C alkyne and nitrile. But here this signal is from carbon dioxide. Carbon dioxide shows asymmetric stretching vibration, which is IR active, and that occurs in the IR spectrum. There are two important modes of vibrations in the carbon dioxide: symmetric stretching and asymmetric stretching. I told you that only those vibrations are IR active which gives you dipole change. Symmetric vibration in the carbon dioxide is IR inactive. Asymmetric stretching vibration in IR in carbon dioxide is IR active. So this signal at 2337 is due to asymmetric stretching vibration of carbon dioxide. So this is not the signal from our compound. So is there any problem in this spectrum? Not at all. We can defend why this signal has occurred. But this is not acceptable as far as industry is concerned, as far as forensic science is concerned, as far as food analysis is concerned. That will lead to false conclusions. In this field, high accuracy is required. But in your research, in your PhD, you can defend this, why these signals have appeared in your IR spectrum. So analysis is very important. Instrument is very important as far as IR spectroscopy is concerned. If someone is analyzing the IR spectrum and the IR room where IR instrument is kept is not closed, so many carbon dioxide molecules will come from the atmosphere. So many water molecules will come from atmosphere, and that will interfere. So the room should be very, very closed. So are you getting my point? Dear PhD scholars, are you getting my point? I think you are getting my point. Okay. Okay. I will proceed further. Those who are listening are getting my point. And those who have kept the phone aside, they might not be listening. This is another compound. So here again we have an carbonyl group. We have an C double bond C in conjugation with carbonyl. Correct? And other functional groups are Cl is there, carbon single bond, oxygen is there is presence of aromatic ring. So all these kinds of frequencies can be expected. So this is the IR spectrum of this compound. Okay. Now, again in this compound, you can see and carbonyl frequency is at 1685. Can you see the frequency at 1685? Can you see the frequency which is at 1685? You can see here. And here, these frequencies belongs to CH stretching of sp3 carbon. We have here this dihydrofuran ring. It is having an sp3ch bond. So these frequencies are due to CH stretching vibrations. And 1685 is due to carbonyl stretching of this ketone group. You can see this band which I am pointing out by using cursor. It is due to carbon dioxide, which is not labeled in this case. And in this spectrum, there are no impurities from there are no signals due to moisture, water molecules. Okay. All other signal, carbon double bond, carbon frequencies, you can see there is a carbon single bond, oxygen. Okay. Now, what I would like to show. Now, this compound is having CH of aromatic ring also. And CH of aromatic rings, sp2CH occurs at which value? Close to 3000. But here you can see some minor signals are there which are not labeled by the analyzer. So, labeling of each and every important peak is very important. And the person who is performing that analysis on particular IR instrument is not aware of what kind of functional groups are there in your compound. So what you have to do, you have to ask for data file from that person who is analyzing your IR sample, and using that data file we can plot the IR spectrum by using Excel, Origin, and these software tools helps us to identify each and every important peak so that you can explain in your thesis. Let me show you second compound. It is also having an carbonyl group. Similar types of linkage is there. Structure is not exactly identical, but I would like to point out one thing. Here the ketone group is present in a ring, which is an 5-membered ring. In second structure, it is an open chain structure of enone system, double bond carbonyl. And I would like to show you the IR spectrum of second compound. This is the second compound. Can you tell me the carbonyl frequency, value of carbonyl frequency in this compound? What is the value? This is the IR spectrum of second compound. Dear scholars, can you tell me? Can you tell me? 1649. Yes, absolutely right. What was the frequency in the IR spectrum of first compound? Let me show you. You can locate it. It was 1685. So first compound is having 1685. The second compound is having 1649. So this carbonyl group of second compound vibrates at lower frequency than the carbonyl group of first compound. You might have studied that whenever there is a ring, rings are having strain, and therefore they are having higher frequencies. As ring size decreases, carbonyl frequencies increases. This is very basic concept. You might have studied. If you have not studied, remember, ring size increases the ring presence of ring increases the frequency, and whenever there is decrease in ring size, frequency increases. So you have to explain why in first compound carbonyl frequency is higher and second compound it is lower. And again you can see there is interference from the carbon dioxide. Huge peak has appeared, and there are some peaks due to moisture, and all other peaks are there, you can see. Okay, up to this point, would you like to ask me any question? If you have question, I will be happy to answer you. I will try to give you answer for your question. If you have any question, the students who are in the third, fourth or fifth year of their PhD, they might be having questions related to their research. The students who are in the first year, they may not have any question. Would you like to ask me any query related to this point, or anything which you would like to ask? I think there is no question, so I will proceed. Now, I have taken the IR spectrum, this IR spectrum from one of the research paper. Here, I have quoted the research paper. Whenever you are using the material of some other person, always remember to give credit. Don't use the material of other people without any credit. I have given the credits here. Okay. Now this is the IR spectrum of an inorganic material. Organic material. Very important things which I would like to discuss. So this IR spectrum is drawn in the origin. Okay, it is plotted in the origin. I will show you how to plot. So this black color spectrum is for Fe3O4, iron oxide, correct? Ferroferric oxide. So it is having an iron oxygen bond that can be detected in the IR spectrum. And the second compound is graphene oxide doped Fe3O4. If you know the structure of graphene oxide, the graphene oxide is having carbon single bond oxygen, carbon double bond carbon, carbon double bond O. These are groups which are there in the graphene oxide. Let me show you the structure of graphene oxide so that you can compare. Okay. Give me 1 minute. So dear scholars, can you see the structure of graphene oxide? Dear scholars, can you see? Yes. So there is presence of carbonyl group, sp3ch, sp2ch, OH group, carboxylic acid. So all these groups will be detected in the IR spectrum. So what I would like to show here that in this IR spectrum, these researchers who have published this research paper on effective chemical vapor deposition and characterization of end of for graphene oxide for high electrochemical performance. So how they have confirmed that graphene oxide is doped in Fe3O4. So can you see the spectrum of Fe3O4 which is given in black line? So always remember metal oxygen frequencies. Again, I'm repeating, metal oxygen frequencies are in between 400 to 600 reciprocal centimeter. So these two signals, you can see doublet type of signal is there. These two signal goes to iron oxygen stretching. Correct? And whenever that graphene oxide is there along with Fe3O4, these two signals are already as it is, which are these iron oxide signal. But in addition to this, you can see this part of the spectrum which is absent in the Fe3O4 is due to presence of graphene oxide, carbon single bond O, C double bond C double bond O. So These authors, researchers have confirmed that graphene oxide is successfully doped in Fe3O4. So as I told you, we can monitor the reactions, what is happened in the reaction, whether our material is formed or not. Is everything clear to everyone? Is these things are clear so that I can show you some more IR spectra. Okay. I will show you some of the IR spectra from publications of my some students. Okay. So this is the publication of one of my student. You can see the paper. Uh, it is an it is on material science, efficient photocatalytic degradation of eosin blue dye and active antibacterial study using nanostructure zinc oxide. So here I would like to show you the IR spectrum only. I will not discuss all other parts. So a material is quite simple: zinc oxide and 5% nickel zinc oxide. So here we can compare the spectrum by analyzing the values. So you can see the metal oxygen frequency of zinc oxide oxygen frequency, and what has happened after doping the zinc oxide with nickel. So you can compare whether frequency is increased or decreased, and what are the factors changing the values. Similar type of spectrum I would like to show you. This is the spectrum of which compound. Let me show you the structure. It is an organic compound from one of our publication. I will show you the structure. So this is the structure of the synthesized compound. So what kind of groups it is having? It is having an carbonyl group, it is having an double bond, and it is having an nitrile function. Correct? So whenever reaction will occur, so you can see, and this ketone group which is survived in the reaction. But what has happened? It is a simple reaction in which there is formation. Claisen-Smith reaction, there is formation of double bond. So as I discussed with you, conjugation will decrease the frequency. And in addition to this, there will be an presence of nitrile signal. I told you nitrile signal is close to 2250 reciprocal centimeter. Let me show you the IR spectrum of this compound. Okay. So you can see the carbonyl frequency is at 1656 reciprocal centimeter, which is quite at lower value due to conjugation. But you can see this signal at 224081, and it definitely due to presence of nitrile. It is not due to carbon dioxide. Remember this thing. So nitrile is confirmed, carbonyl is confirmed, and all other signals you can compare. Are you getting my point? Okay. I will stop the sharing now. I don't think the origin will be analysis by origin will be covered in this session because already it is 11:30. Let's see what happens. At least I will show you the interface of origin. Okay. And we'll try to analyze one spectrum, but we cannot go for full characterization, full IR characterization. Now, some of you might be knowing So, dear scholars, as I told you, in each and every field, this IR technique is used. Some of you might be knowing in cricket, the hot spot technology, that is infrared imaging, or that sneakometer, you might be knowing, you might have seen the DRS system, decision review system in cricket, that is dependent on principle of IR spectroscopy. And how it is using? Infrared cameras are used to detect the heat generated when the ball contacts with the pad glows. There is generation of white spots on the position where that ball strikes. At that position, heat is generated. Similarly, there is change in the lines in the sneakometer. You might have seen, and it is using the principle of IR spectroscopy. IR cameras are there. Let me show you one image. You can see here in this image, I have taken it from Wikipedia. So you can see in the decision review system, the umpires have seen that there is a white spot on the bat. It means the ball has struck on this position, and the umpires now can make the decision. So this is based on the principle of IR spectroscopy. Similarly, for night vision also IR application of IR spectroscopy, there are so many fields in which we can use the IR spectroscopy. Only the thing is that we must know the theory, we must know how to apply the technique for our conclusions, for our results. So, to summarize the things, I would like to tell you that IR spectroscopy is fast, reliable, non-destructive, minimal sample preparation. Actually, sample preparation is not required in the ATR, and wide applicability is there. But limitations are there. Background interferences are there due to water and CO2. Bands are sometimes overlap, which reduces the analysis accuracy. IR itself, only the problem with IR is that we cannot totally rely on IR. For complete characterization, we need, for organic sample, we need NMR, we need mass, we need other HPLC. For inorganic, for material science, we need the XRD, we need SAME, we need TAME, we need XPS, Raman. All other techniques are more useful than IR. But it does not mean that IR is not useful. IR is very fast. And so we can rely on this, but not fully reliable technique. So we can use the IR spectroscopy for wide domain of research. We can go for qualitative, quantitative analysis also. And it is an important technique in modern research. The future direction in the IR spectroscopy will be portable and handheld FTR devices. So we can take along with us the IR instrument. So in future, they may avoid the interference due to these atmospheric noises. There may be advanced chemometrics and AI-based analysis in the future. High resolution IR imaging is the most important thing, and integration with microfluidics. So this was all about the theoretical concepts applicable to your research I have covered. Now we will go for the application of origin software. Now, if you have questions related to this, we will take the questions and I will try to give you answer. You have 1 minute to ask me the question. I think there is no question. So I will go for origin software. Okay. So application of origin software is very important as far as the research in organic chemistry and material science is concerned. Let me share with you screen so that we can see the origin. Now let me open the origin software. Okay, already it is open. I will close it. Okay. Now, dear research scholars, are you able to see the origin interface? Give me answer fastly so that I can cover the most of the part. Are you able to see the interface of origin? It is quite visible. Okay.
Yes, sir. Yes, sir.
Okay. Okay. So by using origin tool, we can draw many types of plots. We can do the statistical plotting, which involves statistical analysis. We can plot any type of spectrum, not NMR. From data, we can plot Raman, we can plot IR, we can plot XRD, we can plot graphs. Several types of things can be done. But today I will show only plotting of IR spectrum. Okay. Let's understand what things are there. You can see at the top left corner, file option is there. Then we have edit, view, plot, column, worksheet, analysis, statistic, image, tools, format, window, help. And at the bottom left corner, you can see there is an line plot selected area. Then we have scattered plots, we have line symbol plot, we have graphs, column graphs, we have stack lines, many things are there. Okay. You will not understand all things immediately. For that, practice is needed, and practice makes us better, not perfect. We become somewhat better due to practice, but not perfect. No one is perfect. So here, this is the worksheet book. You can see we have an X axis, Y axis. And here we will paste the values for which we are going to plot the graph. Is this clear to everyone? In a very simple way, I will be discussing with you plotting of IR using origin. Is this clear to everyone? What I am asking, dear scholars? Okay, I think those who are listening, this is quite clear. Okay. Now, what you have to do, you have to copy paste the data here. Now, I will show you the data from one of my student. Let's take this compound. Okay, give me some time. I will show you a compound 9C. Okay. So what is this file? It is an text document. You can see this type of data file is obtained from the instrument operator from which you are taking your IR analysis. Ask them to provide this type of data file. They may provide in this text document file, or they may give you in the Excel file. No problem. CSV file. Okay. Now what you have to do? You have to just right click and you have to open this file with the WordPad. You have to open this file with WordPad. Now I have opened the file. You can see the values are there. Okay. So different values are there. So what I will do, I will type on keyboard control. I will press the key control A so that all values will be selected. Okay. Now control C, all values are copied. I will take all these values to the origin workbook. And only the thing is that you have to paste the values here. Okay. Is this clear to everyone? Dear scholars, is this clear to everyone? Or shall I repeat the things? Is there need to repeat? I think there is no need to repeat. Or someone is there? We still need the further explanation. No one is there. Okay. Now I will go for selection of these values. What you have to do? Simple thing. You have to select both the axes. Okay. I have selected both the axes. And here at the bottom left corner, you can see the option line. Are you able to see the option line at the bottom corner? Here, this option. Are you able to see? Okay. Only you have to click on this line. Are you able to see the IR spectrum? Are you able to see the IR spectrum? Are you able to see the IR spectrum? Let me see your answers. Yes. Okay. But now you can see it is not a good looking IR spectrum. You can see the range here. How much range is required for that mid IR region? I told you that is 400 to 400 to 4000. Are you getting my point? Okay. So what you have to do? You have to change the scale. You have to change the scale. How to change the scale? You have to select the values first, double click at these values, and new interface will appear like this. Can you see? Are you able to see the new interface? I think all of you. Now here scale option is given. Are you able to see the scale option? Okay. Here you have to set scale option from 400 to 400 to 4000 reciprocal centimeter. Now, at the bottom, you can see one option is there, apply. You have to apply this, then okay. Are you getting my point? Are you getting my point? Okay. I will show you all these things again. So it becomes easy to interpret. Okay. So how you will go for the IR analysis? First of all, you have to open the origin. Okay. I am sharing the screen again. Okay. So what you have to do? I will close this plot. Okay. So again, I am opening the origin to make the things clear. Okay. So what you have to do? Again, I will open the file, data file. So I have this file now with me. I will open with WordPad. Are you able to see the values? Yes. So I will copy all these values so that we can take all these values to origin. So then I will copy paste the values. I will select the here two rows, two columns, and then by selecting on the line, we can plot it. Are you getting my point? Now I will show you one of our graph so that things will become more clearer. Okay. So dear scholars, are you able to see IR plot here? Okay. So again, I will tell you all these things. So we have these values. We have to select it. And we can go for the analysis. Okay. Where is that graph? Let me see. Okay. Now, to obtain all these things, as we have less time, I will tell you. If you get this type of graph, then what you have to do? You have to remove all these values if already are there. Now, we are going to label each peak here. How to label the peak? If you are getting the values, then you have to select the lines here. Just by clicking one pick, your all picks will be selected. Then you have to go for analysis. Okay, again I'm repeating, you have to go for analysis. Then you can see option called as peaks and baseline. Then you have peak analyzer. Again, I'm repeating. For what purpose we are doing this thing? We are assigning frequencies to each peak which we require. So for that, I have clicked on IR peak in the spectrum. Then I have selected the analysis. After analysis, peaks and baseline, and then peak analyzer. Then there is option open dialog. You have to click on open dialog. Okay. Are you able to see new interface here? I think you are able to see. In that, you have to go for find peaks. You can see here option is given find peaks. You have to select find peaks. Then another option is there, which is next. You have to click on next. After clicking on find peaks, then you can see in this IR spectrum and a red line is shown. It means all peaks below to this line will be analyzed. But you can see all peaks are above to this line. So they will not be analyzed here. We need this line above to all peaks. So I will select maximum. So you can see now the red line has disappeared. So maximum is selected, then you will go to next. Again, you will click on next, and you can see here one option, find. Are you able to see the find option? Are you able to see the find option? Dear scholars, are you able to see find option? If I click on find, see here what happens. Okay. Pics are not labeled as I have edited. I will again go on analysis. Some error has occurred. So I will select find pics, then I will go to next, then I will go select maximum, then I will go to next, and here. Now here, as this, actually this option is not needed at all, but I was just showing that this option, why this option is not good. So I will uncheck this box of auto find. What you have to do, you have to click on add. You can see the option add here, and here new interface has occurred. Now what you have to do, you can see the cursor is now changed to some other size. Now what you have to do, you have to select each peak and double click on that peak. So you can see I have selected this peak, and now I am double clicking on this peak. So and line has appeared. Similarly, you have to select all the peaks which you require. So I have selected 4 peaks here. Similarly, I can go for this peak. I will select some peaks only to show how signals appear. So I have selected some peaks here. Then you can see here one option is there, done. You have to click on done here, and after clicking on done, you have to click here on finish. Are you able to see the signals? Yes, I think you are able to see the signals. Then you have to delete all these baseline of P, peak centers, everything. So I will select all these lines and I will click on delete. Now you can see only the peaks which I have assigned. Now this spectrum does not look good. So I will select all the frequencies After selecting all the frequency, you have to click on drop down arrow on your keyboard. All values will go at the bottom. Now you can change the font size. How you will change the font size? Select the values, go for default Arial. The font is default Arial at the top corner. And then you have to select the appropriate font size. Let me select the font size 18. That will look good. For all pics, we have to select this. You can see the font size is changed. You can make this font bold also. You can see the values. Now, you can change the color. Here we have the option to change the color. I have taken the values red. So you can do each and everything in the origin. Now you can see the digits after decimal point. So you can see how many digits are there. 1, 2, 3, 4, 5. You can change the decimal points. How to change the decimal points? Double click on these values. After double clicking, this type of window will appear. And here, one option is there, display format for significant digit to set the decimal places. Generally, I prefer to give 2 decimal points. So I will click on dot. First, you have to click on dot. Then you have to type 2. So you will get 2 decimal points. You have to click on apply. Then you have to click on OK. Can you see? Decimal points are changed. And by selecting, you can take the values anywhere like this. Okay. Now you can see there are 2 decimal points in this. Okay. In this way, we have plotted the IR, and you can see each and every value. As we have less time, I have shown you directly the IR spectrum. Now, what you have to do? You have to click on minimize option, which is at the top right corner. I think you are unable to see it. Okay. So all values are obtained. I will go to the workbook. So this is the workbook. And from which position you have to extract the values? At the bottom part, you can see here we have sheet, baseline, pick centers, everything is there, correct? And you can see at the center all the values which I have labeled. Are you able to see? I think you are able to see. Only you have to copy the values, then open the Word file. You have to open the Word file and copy paste the values here. And you can arrange as per your convenience. So in this way, we can do the IR analysis. So many things are there which I have not explained. Maybe in the next session, I will cover all important aspects of IR plotting. I have covered only 10 to 20% part. There are so many things which we can do. So I will stop the sharing as time does not allow me to continue the lecture. So thank you very much to all research students, all the research scholars for listening this session patiently. Thank you. Thank you very much. I will leave the meeting. The person who is monitoring this session is requested to close the meeting. Thank you.
Thank you, sir. I express my heartfelt gratitude to respected Dr. V.A. Adole, sir, and honorable principal, sir, all the coordinators, and all faculty member and research scholars. So with this, we conclude today's session. Thank you, sir.